This video is going to cover both parts A and B in the Explore section. So problem 1.4.2, use the race time and age graph. So this is the same graph that we had above. A, the line drawn on the graph models the relationship between age and race time. Number 1, what is the approximate slope of the line? Now remember, when we're doing slope, we're looking for the change in y, which we like to call the rise, over the change in x, which we like to call the run. So we're looking for how it changes going up or down, and how it changes going side to side. In this case, the line is going down, so I'll give you a hint, it's going to be a negative rise. So our number, or our slope, is going to be negative. Number 2, how does the slope help you understand the relationship between age and race time? So once you find the slope, you can see how this is going to help us understand the data. Number 3, do you think it makes sense to predict the race time for a 7-year-old student using the line? If so, what do you predict for a 7-year-old? How confident are you in your prediction? So taking a look at the data, you can see if it's going to make sense to use this line to predict the age for a 7-year-old between 6 and 8. And number 4, do you think it makes sense to predict the race time for a 21-year-old person using the line? If so, what do you predict for the 21-year-old? How confident are you in your prediction? So the graph only goes up to 16, but they want to figure out if it makes sense, if we were to extend this graph, would it make sense to predict for a 21-year-old? Part B, some data points are very close to the line while others are far from it. The points far from the line don't seem to fit the model. Find 2 points that don't seem to fit the model. What are their coordinates, age and race time? So when we're looking for coordinates, remember we're looking for parentheses with 2 numbers in the middle. The age is going to go here, and the time is going to go here. So you're finding 2 points that are far away from the line, they're not very close, that you don't think seem to fit, and putting the coordinates for those points. The first one I think I see is this one right here. I'm going to say those coordinates are 10 for the age and 20 for the race time. That first one I'm going to say 10 and 20. It's your job to come up with another one. Number 2, why do you think the points don't match the overall pattern? Explain. Think about the relationship between race time and age. So why don't those 2 points that you found match the overall pattern? And the last question in section B, in problem 4.1, you used a line to model height and the arm span. A, if a 6-foot 9-inch basketball player has a 7-foot 5-inch arm span, would that data point fit the model? And question B, would you plot the data point on, above, or below the S equals H line? Remember our S equals H line just cut our graph in half diagonally. Do you think this point that you found in question A is going to be on, above, or below a perfect line through the middle of a graph?